Hi guys, welcome back to NB Learning. Today we are going to discuss about types of boiler control. Before starting the video, it is requested that kindly subscribe my channel for more videos. Let's we discuss that types of boiler. What are how many? There are how many controls of boilers? There are three main types of boiler control. One is on-off system, second is positioning system, and third is modulating system. One by one, we see the detail of the systems. First of all, is on-off control system. On-off control system. In this method, actually, this method is applied to the small boiler which have low generation capacity and low fuel handling. When load demand increase, then the boiler firing start, and when the load demand decrease below a certain level, then the burner becomes off. This is called on off system, which works according to the steam load demand. And this system is feasible for small boilers. Second is step up and step down. Step up and step down strategy. Firing rate is set, means that there may be one firing rate, two firing rate, or three firing rate. First is the first may be low firing rate and high firing rate, maybe medium firing rate. It is according to the steam demand load. When the steam demand or load increase, then the firing goes to high firing rate, and when the steam demand become low, then the burner goes to low firing rate. This is called step up and step down firing control system. And next one is the positioning system. In positioning system, fuel valves are connected through a camshaft, and the FD fan is also connected through a rod with a camshaft, and finally the cam rod is connected to an actuator, which gains signal from the steam pressure. When steam pressure increase or decrease, then this actuator, you see in this slide, this actuator move and maintain the air fuel ratio. But this is a very typical and old system. In the system, there are, you see that there are a lot of links. Due to links, these links lose with the passage of time, and one of the major drawbacks of a system is that it does not provide any type of precision, because in the system we do not monitor the fuel flow or air flow. Also, we do not consider the temperature compensation. So this is a typical and old system. And there may be two strategies: single point positioning system, and maybe parallel positioning system. You are seeing the slide picture, which is the single point positioning system. And parallel positioning system, maybe there may be two actuator. One is linked with the airflow, and second is linked with the fuel flow. This was our positioning system. Next, there is a terminology used in boiler control system, is called multi boiler staging. Multi boiler staging means, when we connect a number of boilers through a single header pressure, that when the steam load increase or decrease, then the multiple boilers on and off according to the steam load demand. This is called multi boiler staging, and this is basically the example of on off control system. Third one is the major control system. It is called modulating or metering control system. This is the most advanced, most precise control system. In the system, flow of air is measured, also the flow of fuel is measured, and also there is a temperature compensation is considered. So all these things make this control system very effective, very precise. But this is its initial cost is greater than the traditional control systems. In this control system, there may be a cascade control loop, and cascade control loops are used where there is a slow where we want slow response and precise response. So this was our modulating control system. The difference between the positioning system and modulating control system is that in modulating control system we will consider the flow of fuel, flow of air, and also consider the ambient temperature compensation. So next one is oxygen trimming control or excess air regulation control. uh, this uh, this control systems works to make efficient the firing rate. Uh, an oxygen analyzer is installed on the exhaust flue gases of the boiler, which continuously monitor the oxygen percentage, excess oxygen percentage, and this transmitter gives signal to the air controller, and air controller reduce air accordingly. If the excess air is increased, then the O2 analyzer detect the excess air and give signal to the air controller, and air controller finally decrease the air demand to increase the efficiency. As you know that when the excess air increase, then the efficiency, firing efficiency goes down, because the excess air takes the temperature of furnace and goes in the atmosphere. So to reduce NOx and firing efficiency, oxygen control is very crucial. And next one is air fuel cross limiting control. Air fuel cross limiting control is basically the control. This control is valid in the areas when we want to increase the safety of our boiler. Air fuel control limiting cross limiting control means that when the load on the boiler increase, then the air increase first and then fuel increase. And similarly, when the load on the boiler goes down, then the air increase first and then increase the fuel. So this was called cross limiting control. This is the most advanced control system to reduce the explosion in the boiler. Means that air is increased first and fuel is decreased first in the when the load become high, then the air increase first, then fuel increase. When the load goes down, then the fuel decrease first and then decrease air. Next one is a table. You can see that as the ambient temperature increase, then the excess air increase. Why excess air is increased? Excess air is increased due to the increase of volumetric flow rate. As you know that when the temperature of any gas or air goes down, then the volumetric flow rate increase. So these things happens in our ambient temperature, in ambient atmosphere, and this compensation is also provided in the modulating control system. So accordingly, excess air is controlled. Combustion control scheme. Now we discuss about the combustion control scheme. There are basically three combustion control scheme. One is called series control scheme, second is parallel control scheme, and third one is the parallel plus series control scheme. Series control scheme. What is the series control scheme? Series control scheme is that basically, first of all, when the load demand on the boiler increase, then the steam pressure goes to the air controller. Air increase first, then the air controller signal goes to the fuel controller signal, then the fuel increase. This is called the series control system. And in parallel control system, the steam pressure simultaneously goes to the airflow and fuel flow. And in the third control scheme, which is series plus parallel, is in this steam pressure control the fuel flow, and the steam flow will control the airflow. This is called series plus parallel strategy. Control schemes are strategies. Now we're going to discuss about the boiler drum level. Today our topic of discussion was the boiler control system and how to control the boiler drum level. So boiler drum level is very important. As you know, in the boiler it has very important and crucial role. If the level of the boiler increase, then our carryover will be increased, and this will harm our steam turbine or superheater, and it will ultimately reduce our efficiency. So how to control our boiler drum level? There may be three control systems. First one is single element drum level control. In this control system, first of all, there is a steam drum and a level transmitter is installed on the steam drum. As the steam drum level goes down, the level transmitter gives signal to the controller, and controller gives signal to the control valve, which increase or decrease flow to the boiler drum. This is called single control element. This is this may be used on a very small boiler in which there is no swelling or shrinking effect. Next one is the two element drum level control. In this control, two elements are involved. First one is level transmitter, and second is the steam flow transmitter. Both the two transmitter give signal to a controller, and controller, after monitoring the both signal, give the signal to the control valve, which increase or decrease water flow in the drum. Third one is the three element level control. In three elements, there is level transmitter, steam flow transmitter, and third one is water flow transmitter. Both the three signals, both the three elements give the signal to a controller, and controller finally generate a signal to the control valve, which increase or decrease flow of water in the drum. Now, one thing we discuss here, that why we need three element control loop. Three element control loop, basically we need that when the load on the boiler increase, then the pressure of the boiler drum will goes down. When the pressure of the drum goes down, then the level of the drum increase. When the level of the drum increase, why the level of the drum increase? Because the pressure on the surface of the water exerted by the water vapors has suppressed the water level due to level is showing low. But when this pressure release and steam flow increase, then the water level increase, which is called the swelling of water. And if we have only single element, means that if we have only level transmitter, then level transmitter will read the wrong level, because a level transmitter tells that the level of drum is increased, and it will give signal to the controller, and controller gives signal to the final control element, and level of the drum increase further. So there, this single element or double element maybe face some issues, but in the three element control loop, we are seeing both the three things, means that how much water is goes inside the drum level, how much steam is goes outside, and what is the level of the drum. Both the three signals are analyzed inside the controller, and then signal is generated to the control valve to increase or decrease the water drum level. So these elements play a vital role in the swelling and shrinking effect. Shrinking effect means when the load demand decrease, then the boiler drum level increase. When the boiler drum level increase, when the boiler drum pressure increase, then the boiler drum level becomes suppressed and goes down. So in this case, steam flow ft play a vital role and tells the controller that what is the steam demand, and according to the steam flow and steam demand, water is permitted inside the drum level. So this was our topic today, in which we have covered two major areas. First one is the boiler control system, and second was the how to control boiler drum level. So guys, see you in the next video.